Bismillahirrahmanirrahim. Assalamu alaikum. Today we will perform the practical relating to determine the density of spheres in fluid. So the apparatus which we have required in this practical, that is drag coefficient of sphere apparatus and different spheres of different materials. First of all, we would have to discuss about the drag forces. As we all know that viscosity, if we describe viscosity, so it means the bonding in the layers, in between the layers of the fluid, and how much it will resist the particle moving against these fluids. So, if we look at the apparatus, we have two cylindrical tubes. We can also compare the viscosity of two different spheres, two different fluids with the help of this apparatus. If we want to discuss about the viscosity of the fluid, so we would have to fill these cylindrical tubes with two different spheres, with two different fluids. If we want to compare the density of water with, let's say, kerosene oil, so we would have to fill the cylindrical, one of the cylindrical tube from water and the other from the kerosene oil, and then we would have to draw spheres of similar diameter in each of the fluid, and then we will have to note down the time which is required to attain the given distance or achieve the given distance in that particular time. If the resistance of the fluid is higher from the other fluid, so it will take more time than the other one. So, and the second procedure for performing the practical, we would have to note down the sink speed of different spheres of same diameter. And as well as we would have to change the spheres of same diameter, and we would have to note down the sink speed of the spheres in water. If we discuss about the spheres and the material and the densities of those spheres, so we have nylon sphere, material is of nylon, and the second one is of a type of plastic material which is POM, polyoxymethylene, and the last one is of aluminium. So if we discuss about the density of nylon, so it's given to us which is 1.15 gram per centimeter cube. Then the second density, the second material is polyoxymethylene, and the density of the material polyoxymethylene is given to us which is 1.86 gram per centimeter cube. Then aluminium have maximum density with respect to these two above mentioned material. So the density of the fluid of the material aluminium is 2.43 gram per centimeter cube. So the procedure for calculating the sink speed of different spheres in water, we would have to draw the sphere from the upper portion of the apparatus, and when the sphere reaches up to this black o-ring, we would have to switch on the stopwatch, and reaching up to the end point of the o-ring, we would have to stop the stopwatch. This will be the value of sink speed for a single particular material. Then we also know the given distance from through which we can calculating the sink speed, that is given to us, which is fixed, and that is 1 meter. If we calculate the coefficient of discharge for the and the drag coefficient for the given material, so we have formula given to us, that is CD, coefficient of discharge, which is equal to 4 by 3 density of the spheres minus density of the fluid, then into gravity and as well as diameter of the sphere, which is given to us, that is 10 millimeters. Then divide the whole values of the this formula, divide by density of the fluid into velocity square. If we just repeat the formula, that is CD is equal to 4 by 3 density rho S minus rho F into G into D divided by rho F, which is density of the fluid, into velocity square. Now you would have to note down the sink speed for different materials. So this is the sphere of material nylon. We would have to drop the sphere from the in the fluid, and while dropping the material, you would have to note down the sink speed of these spheres. Reaching to the end point, we would have to stop the stopwatch. So the time which it achieved, which it gains from the starting point up to the end point, the distance is given to us, which is 1 meter. It is 5.46 seconds. Now removing the sphere from the apparatus, there we have two flow control valves given. What the first one is connected with the cylindrical tube, and the second one is connected with the first one. You would have to unlock the first drain valve, which is connected with the cylindrical tube, then close the same valve. After that, the sphere is dropped from the cylindrical tube up to the second drain valve. Then you would have to unlock the second drain valve anti-clockwise. Clockwise. The sphere is removed. So this is the procedure while removing the sphere from the apparatus. If you would have to, if you allow both of the valves to unlock drain valve, so all that fluid will be drained from the cylindrical tube. Now we would have to use the second material. The density of the second material is greater than the density of the nylon, so we would have to drop the sphere of material polyoxymethylene, and while reaching to this point, this black o-ring, we would have to start the stopwatch, and reaching up to the end point, the distance is given to us, which is 1 meter. We would have to stop the stopwatch and note down the sink speed of the material POM. Let's start. And then stop. So it the total time it consumes from reaching from achieving the distance of 1 meter, that is 3.12 seconds. Now again remove the sphere from the cylindrical tube anti-clockwise. You would have to open the first drain valve and close it, and for the second we would have to open the drain valve clockwise and remove the sphere. So this is the reading for the second material. Now we would have to use the sphere of aluminium. Its density is double than polyoxymethylene, so it will gain less time to cover the distance of 1 meter. Starting from the black o-ring and stop. So it just consume 1.85 seconds, attaining the distance of 1 meter. If we discuss about the losses, the errors that are avoid parallax error, as well as reaction time error, and you would have to make sure that the sphere didn't collide with the boundaries of the cylindrical tube, because it resists its actual velocity, or you can say actual speed. If you want to calculate the speed of the sphere, so you would have to use the formula distance divided by time. Distance is given to us, which is 1 meter, and time we will get from the stopwatch. If you have any question, you can ask. Thank you so much.